Hey, how are you all? Today we are going to learn about this lead code number 105 question where we are given some pre-order sequence, in-order sequence where we have to construct a tree with these two sequences. Given two integer arrays, this and this is a preorder traversal of a binary tree, and in-order is the in-order traversal of the same tree on struct return the binary tree. Okay, the same tree is pre-order sequence and the in-order sequence is given. So how are we going to solve this question? Okay, let us think. See, one thing you should understand is that making errors are necessary to learn code, because it is the main thing you have to do. So if you make error, that doesn't mean you are not learning it. You are learning straight away. Watching the tutorial is not proper learning, or we can say it's not the learning. Okay, first of all, let us see the examples. Okay, what is the input? Pre-order. Okay, just 3 9 20 15 7, and in order something like 9 3 15 20 and 7. Okay, this is like this. Yeah, so let us think how are we going to solve this question. See, pre-order sequence, first of all let us make an index which we call as pre-index, and it is starting from the first. Okay, 0 with index. Okay, so 3, there is 3, so make a node. Okay, new node we can say. Let us call it a root. Yeah, now if we increase the index, there is a 9, but we don't know where the 9 will come, if it is coming in the left side or in the right side. Here our in order sequence would help. Okay, see, let us find it in the in order sequence. What is the pre-order sequence? Pre-order sequence is something where you get the root first, then you get the left, then right. Yeah, and for the in order sequence we get the left, we move on to the left, then root, then right. So in the pre-order sequence you can get the root firstly, but you don't know whether it is left or right. Yeah, because there is no minus or anything. Okay, so in the in order sequence you have to find 3. Let us find 3. Here is it. So in the left part of it is the left side, left subtree, and the from the right part it will be right subtree. So the 3's left part is 9, so 9 would be its left part. Okay, so what do we have telling, just write it because it will be helpful. First thing first we have done is making new node. Then what do we do? We search in order sequence. Yeah, then we increase the index. We have got the index. We are doing it by recursion only, because most of the questions are done by the recursion only. So fourth we will be what we are doing. First we search it, we got the index, let us call it as in index. Okay, in order index we can say. Then what we will do, we want left. We have come to the 9. Okay, we have come to the 9. Then we'll call the same function again, and um, and the but for the left part. Okay, for the left part. And the range, left and right range would be from we can say from left to index -1. Yeah, this is the range for the left part. Yeah, like 9 in the left part we have made. Then again left, if you see again left, there is nothing, null, so null. For the right there is also null, nothing, because left will if you do like, see, there is right. If when we are getting null, best case we can say. Yeah, when we are getting null, when, see, left and right in the 9 only. Yeah, for this left part. Then if you do like index -1 range left to index -1, then the right part L is greater than R. Okay, L is greater than R, then this is best case hit, so we are gonna return the null thing. Okay, then again it would return, then return. Okay, and the right part would be for 3 is from the range index +1, that is 15 to 7. Okay, 15 to 7. Okay, it is the right part of it. Okay, okay, so also we have to make index ++, obviously. Yeah, before null thing hit, you have to index ++. Okay, then again make a new node 20, then search, make new node, search in Inorder, found, then the increase the Inorder sequence. Okay, preorder sequence, and you found the ranges 15, so 15 will be coming in the left part. Yeah, then again null, then again return, and then for the right part it 7, then again null. Okay, that's how you solve this type of question. So what do you need? Let us make a new function, because here it is not written like, let us call it helper function, which will help us to in this question, because we need some arguments, more arguments, that is we need preorder sequence, preorder index, we need left, we need right. Yeah, like us write int and address int left and int right. Yeah, let us first of all complete this function. Base case, if you want to know base case, if left Let us write it left because we don't want to overcomplicate it. L greater than R, just return null. This is the best case. Yeah, we are making a new node, call it as root new node tree node, yeah, which is pre-order of pre-index, yeah, then int in index would be equal to search it in order, obviously, yeah, in order, left, right, and the value is pre-index. Okay, then we are just going to increase pre-index, yeah, for example it comes to the 9, and we're calling the same function, yeah, but for the left part, yeah, in order pre-index, left will be left, right will be for the left part only, it would be in index -1, for the right part it will be calling the same function, but for left part would be this, right part is right, okay, for the right part, okay, let us call tree node star root left. We don't need tree node because roots left part, roots right part, yeah, nice, okay, but we're calling the same function, increasing in order. Let us write the search function also, yeah, int search in order int l int right int value, okay, let us search it very easily for int I0, you can say L, sorry, I less than R I plus plus, let us find it if in order of I is equal to value, then just return I, otherwise return -1. This is the extreme case, that is if it is not found. um, okay, let us call it helper preorder inorder preindex, it is address int pre, let us call it a 0. We're gonna call L and R would be like inorder index size -1. Wait. No. Preorder is preorder. Sorry. Also, you have to return, na? Okay, wait. What it says? Error non-void engine does not return value. Counterparts. Wait. Return root. Let's see. See, one error is there, is that nice. Time complexity, obviously it is calling the search function also, so this is a big of n square time complexity, but you can improve it by using a hash map to store the indexes. Let us solve it by let us optimize this solution. Okay, see, we are doing like it is big of n times, it is doing the helper function is working for n times, and also we're searching the element in the in order sequence, so the big of n square the time complexity is, but we want to minimize it or optimize it to let us say for big of n. How are we going to solve this? So we need what you call a hash map, where we are just going to store the in order value to our indexes. That's how you are going to search the indexes very fastly, like big of 1 time complexity for unordered map, you can say. Yeah, let us make it. Also, I have to say one thing is that pre-index is passed by reference. Why? Because if you don't pass it by reference, then the index pre-index will not change um, in like the globally. It will change only in the locally. Okay, in this function only, it will not change outside this function. So let us see what is happening if we don't pass it by reference. Runtime error and all these problems will occur because you are moving like this. Like the preorder sequences index is not our increasing globally. If you want to increase, like you want to change, now you have to pass it by reference only. You want to see the changes in the function or anything, you have to pass it by reference, then only you will, otherwise it will be like in one only. Okay, always pass it by reference because you have to change it in all the functions, else you will not be getting things. It's changing here also, pure indexes there, here the changes will occur, otherwise it will not. Okay, let us now make a unordered map. Okay, let us make unordered map which will have int and int. One is value, like the value to indexes. Okay, let us call in order index, in map. Okay, it call in map. Okay, okay, for int I equal, see here you are using it outside, so that doesn't plus only, you inside the function, then the problem will come occur. See, if see, wait a minute, I'll show you. 0 less than index, plus yeah, in map of in order I is I. So let us say it is working for n times. Yeah, all the what value to index is stored. Okay, stored in the map, then it is very easier for us to search it in the map, because time complexity here to search tc will be big of 1, because it is an unordered map. Yeah, that's what is the search function here. Now don't need it. We need in index. Let us find it in the what, in it is found, it will be found. Okay, in map yeah, don't need it, we only need unordered map. Yeah, also let us change it in map and just remove it, and let us see. So like map is very nice. Okay, in map in map. Hash map is a very important topic to study. Where? Sorry. Yeah. Now see that how many seconds, milliseconds, and bits changed. Why? What's up? What's up? Oh. TLE.
Habina?
Wow. It's showing TLE. How? Why? I don't know. Let us think. Okay. See, the problem is that you have to pass it by address because the copy is made. Okay. The copy is made by n times. So big of n to n square would be optimization purposes is not met. Also, I can do one thing to not pass it by reference is to use it globally. Yeah, let us use it as globally, like in here. Yeah, also this thing, use it globally, no matter. Now you do not need to pass these things in map and indexes, no need to pass it. Yeah, also here you do not need these two things, just no need to pass it by reference. Now wait, let us remove this. Yeah. I think let us see. Where? Oh, sorry. Where is the L only? L. Yeah. No problem. Okay. Thanks. Let us solve another question, okay? Which is our transforming binary tree into sum of trees, okay?
Habina?
Okay. Let us print it. Okay. Let us see what is coming. 1 2 7 1 2 3 4 5 करते ना. 2 1 2 3 4 5. Okay, 1 2 3 4 5. Okay. Now we need the SumTree. Okay, SumTree. Let us make it. Okay. Void SumTree. Let's pass the node. Yeah. If let us make it first of all simpler that our root is null. That means root has all these things. Return root's value. One thing also, if root null, return oh let us make it see out. Let us see out. Got it. Just return, no need to print anything. Yeah. Next we are see if it is not there, just SumTree. Roots left part. SumTree for the right part. We have the faith that it would print these things. Okay, then last thing we have to do is that root data plus equal left sum int left sum int right sum. Let's add both this thing. Okay. We need int because it had to pass some value also. Need the left sum also, right sum, because we have to add it. Let us write it int 0 return plus roots data. Just return it. Oh, we have to call this, no? Some see out. Let's see. 15. Wow. Remove this thing. Five. We have to try run only. Let's see. 1, 2, 3, 4, 5. Okay. Root is not null. Then it is left part. Okay. Again call, not null. Left part is null, returning 0. Then the right part is also returned. Right sum is also returning, but 0. A. Then it would return left sum plus right sum plus roots data. That is 2. It is 2. Yeah. Then for the right sum, left, again left, 0, 0. Yeah. Then return it be 4. Then its right part, return will be 5. Just add about this. 4 plus 5, 9. 9 plus 3, 12. 12 plus 2 plus 1 is 15. Should return 15. Why it is not returning 15? Should return. Oh, what? This is the error, bro. Yeah, I said 15 would be our answer because I have made this type. Yeah. Thanks. Bye. It is the binary tree are at the verge of ending. I think at most you will be getting 2 lectures of it or 1. It depends. Thanks. Bye. Like, share and subscribe and comment also.